Review of trigonometric equations. First, we have basic trigonometric equations. Basic trigonometric equations. For example, solve the equation. We have 4 sine theta plus 2 is equal to 4, and we would like to solve it on the interval from 0 to 2 pi. So to solve this from 0 to 2 pi, first we solve for sine theta. We isolate that sine theta first. Okay, so bring this over. I have 4 sine theta is equal to 4 minus 2 is 2. Divide by 4. So sine theta is 2 over 4, which is 1/2. So sine theta is 1/2. Let's consider basic trigonometric equation, because then we need to find, first we find the reference angle, theta reference. The reference angle we are finding using the chart. For what angle sine theta is 1/2? For what angle sine theta is 1/2? Sine theta is 1/2 for 30 degree or pi over 6. So the reference angle is pi over 6. The reference angle is pi over 6. Now we need to complete the rest. So we are using where the sine theta is positive. Sine theta is positive. Add sugar to coffee. Sine theta is positive in the first quadrant and in the second one. So we need to find this angle and we need to find this angle. And the reference angle is between the terminal arm and the x-axis. So here is my reference angle. So one solution is the reference angle, which is pi over 6. And the other solution, if I go from 0, here is pi over 2. Here is 180 degree, which is pi. And that pi we need to think in terms of 6. Pi in terms of 6 is 6 over 6, right? So we have 6 over 6. And this angle is short of 1/6. So what's the measure of this angle? If I have 6 sixes would be the pi. And now I'm short of reference angle, which is 1/6. So this angle is 5/6. So my theta is my reference angle, which is pi over 6. And the second angle, which is 5 pi over 6. And that's my solution. B, from basic trigonometric functions, B, we have cos 2 theta plus 1 is equal to 0. I bring the 1 over, solve it, isolate for cos, bring this 1 over. So we have that cos 2 theta is equal to, bring this over, minus 1. Now, we treat this 2 theta as just 1. That's basically we need to go 2 revolutions. Whenever you have 2, you need to go 2 revolutions. Whenever you have 3, you go 3 revolutions, and so on. Okay? So for cos theta, where the cos is equal to -1. If I look to my chart, we don't have the value -1 for cos. Cos doesn't have the -1. So I'm getting the value from the graph. I know that cos is V-shape. So here's my 2 pi. Here is pi. So cos is -1 at pi. So we write that 2 theta is pi, and I need to go 1 more revolution. Another negative 1 is right here. So here is 2 pi, here is gonna be 3 pi, because here is half and half, right? So this one is 3 pi. Or in other revolution, you can think that you go you go 2 pi further, plus 2 pi, right? 2 pi further is your next revolution. Whenever you have 2, you need to go to what? 2 revolutions, because the graph is squeezed. The graph is squeezed. And we are solving, of course, this on the 0 to 2 pi. So then we can divide. So we have 2 situations. Cos theta is pi, and 2 theta is 3 pi. So then we divide by 2. Then we divide by 2. This cancel out. So my theta is pi over 2. And my theta is 3 pi over 2. So that's my solution, that theta is pi over 2 and 3 pi over 2. If you keep in mind that whenever you have 2, you go 2 revolutions, whenever you have 3, you go 3 revolutions, and so on. So first establish for regular 1 revolution, and then keep adding 2 pi, 2 pi, 2 pi. That's how you get the next revolutions. Now we have trigonometric equations with one function in quadratic form. That's the second type of trigonometric equations. Okay, so for example, this would be 2 sine square theta minus 3 sine theta plus 1 is equal to 0. And we would like to solve it for theta between 0 and 2 pi. We'd like to solve it for theta between 0 and 2 pi. So first we need to factor. How can we factor this? If we think that my sine theta is t, then what we get? We have 2t squared minus 3t plus 1 is 0, or we can think that's x. Then this is quadratic equation. We need to factor that quadratic equation. So this one can be factored 2t and t, and this can be factored minus 1 and minus 1. Or 1, 1, but when I cross multiply, I need to have the middle term. When I cross multiply, I'm getting minus 2t, and minus t gives me minus 3t. So my factorization is right. So this is my one factor, this is my other factor. So this quadratic equation can be factored 2t minus 1, and then t minus 1 is 0. But my t was sine, so for my case, I'm getting 2 sine theta minus 1 times sine theta minus 1 is 0. T was sine theta. Okay, so once we factored this out, then we take each bracket to 0. So we take 2 sine theta minus 1 to 0, and we take sine theta minus 1 to 0, and then solve it. Then we get the basic equation. Bring this over. So we have 2 sine theta is 1. Divide by 2. So sine theta is 1/2. So now we need to have theta reference. Theta reference we get from the chart. Sine is 1/2 for what angle? Sine is 1/2 for pi over 6. Now complete the chart where the sine is positive. Sine is positive. Add sugar to coffee. Positive is right here and right here. So that's my one angle and that's my other angle. So here is pi. We are short of the reference angle. Pi is 6 over 6. Minus 1/6 is 5 pi over 6. So this part is the same as the previous example. So theta is pi over 6 from the first angle, and then this angle is 5 pi over 6. this one. Now the second part, this bring over. So we have sine theta is 1. Sine theta, we don't have it. We are taking this from the graph. I know that sine is the S shape, 2 pi and pi. So sine is 1 right here. 1 is right here. What angle is it? Pi over 2. Theta is pi over 2. So the solution are those two. So my theta is pi over 6, 5 pi over 6, and pi over 2. And the third type of trigonometric equations is trigonometric equations with two trigonometric functions. With two different trigonometric functions. So for example, we have 3 cos theta plus 3 is equal to 2 sine square theta, and we would like to solve it between 0 and 2 pi as well. So if we have two trigonometric functions, we have cos and sine. First step we need to do, we need to change one of those functions to the other. We need to have on one and only one function. So how can we change? We are using the fundamental identities. We know cos we cannot change, but sine square shows up somewhere. We know that sine square theta plus cos square theta is 1. That's the trigonometric identity. If I bring this over, I'm having sine square theta is 1 minus cos square theta. 1 minus, so instead of sine square, I can substitute this part, 1 minus cos. Okay, so on this side, I will have 2 times, and instead of sine square, I'm substituting 1 minus cos square theta. And the rest I copy, 3 cos theta plus 3. Now we need to multiply this out. Now I need to multiply the 2 out. So I have 3 cos theta plus 3 is equal to 2 minus 2 cos square theta. Quadratic equation. Now this equation became a trigonometric equation type 2, that we have quadratic equation. So we bring everything over, we need to factor and so on. Bring everything over. So this cos goes on the other side, so it's gonna be 2 cos square theta. Now I have plus 3 cos theta. Then I have plus 3 and minus 2, because this 2 I will bring it over. Plus 3 minus 2 gives me plus 1 is equal to 0. So now we need to factor. Now we need to factor this one. How can we factor? How can we factor? I treat the same, that this is my 2t squared plus 3t plus 1. So t squared, 2t squared is 2t times t. 1 is 1 times 1. When I cross multiply, I'm getting 2t plus 1t gives me 3t. So that's right, the factorization is right. So my one bracket became 2t plus 1, and my other bracket becomes t plus 1. Okay, but my t was cos. My t was cos. So what we are getting? We are getting 2 cos theta plus 1 times cos theta plus 1 is 0. I just rewrote this factorization on the bottom. I rewrote it in terms of cos. Then we take each bracket to 0. So 2 cos theta plus 1 to 0, and cos theta plus 1 to 0. Then solve it, bring this over. So we have 2 cos theta is equal to -1. Divide by 2. Divide by 2, so we have cos theta is equal to -1/2. We do not worry about negative for now. We just find the reference angle referring to 1/2. For what angle cos is 1/2? Using my chart, cos is 1/2 for pi over 3. So my reference angle is pi over 3. Now I need to complete where the cos is positive and negative. So I'm charting my add sugar to coffee. Cos is positive in the first and in the second one, but we talk about negative. So I'm looking for this angle and I'm looking for this angle. So this part, this one is pi, this part is pi. I think I need to do it bigger. I'm rewriting this to make it bigger as so I'm looking for this angle and this angle. So this part, if I open, it's 180, which is pi. In terms of third, pi is nothing else but 3 pi over 3, 3 over 3. So I subtract that 1/3 because I'm short of that 1/3 is my reference angle, which is this one. So this angle is 2, so we have theta is equal to pi over 3. And now I'm adding, because I'm a little bit more than the reference angle. So I'm adding 3/3 plus 1/3, which is my reference angle. It gives me 4 pi over 3. Okay, that's not the end yet, because now we need to solve this part. Cos theta plus 1. Bring this over. Cos theta is equal to -1. And get this from the graph V shape. 2 pi, pi. So -1 is right here. So 4 pi. So theta is pi. So then my final answer are those three. Theta is equal to 2 pi over 3, 4 pi over 3, and pi. One more example with those ones, with 2 trigonometric functions. Example B. We have cos 2 theta plus 3 is equal to 5 cos theta, and theta is between 0 and 2 pi. We have theoretically the same function, cos and cos, but it's considered different function because we have different angle. This one is cos 2 theta, and this one is cos theta. So we need to have one function with one angle, the same variable. So cos 2 theta we can change. We know that cos 2 theta is cos square minus sine square. But I cannot change to this form because if I substitute, I will have still two different functions. I would have cos, sine, and cos. So this sine we need to change. We know that the sine square theta plus cos square theta is 1. I can bring this over. I know that the sine square theta is 1 minus cos square theta. So now this part I can substitute to this one. So I'm getting then my cos 2 theta is equal to cos square theta minus, and make sure you put in the bracket because we need to distribute that bracket. We need to distribute the minus. So we have that cos 2 theta is equal to cos square theta minus 1 minus minus gives me plus cos square theta, and that gives me 2 of them. Cos square and cos square gives me 2 cos square theta. So I have cos 2 theta is equal to 2 cos square theta minus 1. So either you do little derivation as I did, or you remember the second formula. That's basically this formula what we have cos square theta, cos 2 theta is 2 cos square minus 1. Okay, so now instead of cos 2 theta, I'm gonna substitute this cos 2 cos square. So we have 2 cos square theta minus 1, and then I have plus 3 is equal to 5, and we have cos theta. Okay, now I have one function with one variable theta, so I can, it's in quadratic form, I can bring over everything and factor as we did before. So we have 2 cos square theta, then bring this over, minus 5 cos theta, and then minus 1 plus 3 is plus 2 is equal to 0. Now we need to factor as we did before. So that cos square we can treat as t, or we can keep going that this one is cos theta and cos theta. And 2 can be factor 2 and 1, but I need minus, so I'm going minus 1 minus 2, and I cross multiply, I'm getting 2 times minus 2 is minus 4, and then minus 1 gives me minus 5 of this cos theta. So this is my first factor, and this is my second factor. So I'm having that 2 cos theta minus 1 times cos theta minus 2 is 0. Once we have in factor form, we take each bracket to 0. So we have 2 cos theta minus 1 to 0, and then cos theta minus 2 take to 0. Then we can solve it as before. We have 2 cos theta is equal to 1. Bring this over. Now divide by 2. So cos theta is divided by 2 1/2. Now we need to find the reference angle, theta reference. We are getting this from the chart. Getting this from the chart. Cos 1/2 is pi over 3. Then we need to check where my cos is positive and complete the angles. So I'm drawing the chart, and we have add sugar to coffee. Cos is positive in this part and in this part. So first is the reference angle, and the last one is the whole revolution, which is 2 pi, but 2 pi in terms of thirds. 1 pi is 3/3, and another pi is 3/3, so 2 is 6 of the thirds pi. That would be the whole revolution, and we are short of 1/3. We are short of 1/3. So the theta is the reference angle, that's my 1 theta. And the second one is 6/3 minus that 1/3, gives me 5/3. And now we need to solve the second one, bring this over. We have cos theta is equal to 2. 2 that we don't have in the chart. I'm checking with my graph. 2 pi, pi. My graph is only up to 1. So there is no theta that goes up to 2. So theta, no theta. No theta for this part. So the solution to the whole equation is the solution from the first part.